How does an elevator work?
Good question. I really don't know.
After hours of thinking about what my son had asked me, I started to research about how did elevators work. Using Google, Wikipedia, and Yahoo, I found lots of information but not a complete answer. Finally, in YouTube, I found this video that explained the importance of pulleys in an elevator.
A pulley is a wheel used to transmit power or force by means of a belt, rope, or cable. A pulley can be used to change direction of a force, or in a variety of combinations, can be used to gain mechanical advantage and magnify effort in lifting a load. With a single pulley, there is no mechanical advantage, so the force applied to pulling the rope must be equal to the weight of the load to lift it.
However, this wasn't enough. I had the idea of contacting the creators of the amazing MITSUBUSH elevator, Angelina and Marianne. Good morning, ladies and gentlemen. Today we're interviewing Angelina and Marianne, two professional engineers that are building a model elevator consisted of 6 pulleys. The purpose of this interview is to learn about elevators, how elevators work by pulleys, what are the physics behind all this, and especially why does the counterweight of the elevator must be equal to the one of the elevator car. So, Angelina, please explain to us how does elevator work?
Okay, James. Inside the shaft of an elevator, there is a series of cables attached to the elevator car that run over a pulley connected to an electric motor. On the other end, the cables are attached to a counterweight that goes the opposite way of the elevator car. Pulleys are used to change the amount of force needed to exert in lifting objects. Knowing this, we know that the counterweight reduces the power to lift the elevator in a minimum.
Very interesting indeed. I've always been bad at math. So, okay.
To construct the model elevator, a carton box will be used as the elevator car and pulleys will be constructed around it to make the elevator car go up or down. To make the elevator car move, 2 small holes will be made at the top and at the bottom of the elevator car with a hole puncher. After that, a piece of string at the bottom and 2 pieces of string will be tied at the top of the elevator car. Now, to make the elevator rise, the pulleys will be made with 6 spindles that will be attached in a line, so 4 spread at the top and 2 spindles will be aligned at the bottom of the wooden frame using silicone glue. In each spindle, the strings coming out of the elevator car will pass over them. The string attached to the bottom of the elevator car will loop over spindles 1, 2, 3, and 4, and the strings coming out of the top of the elevator car will loop over spindles 5 and 6. At the end of spindle 6, a piece of string should be left over and a counterweight that will be used as a mast will be attached.
Okay, first we have to draw the free body diagram. We know that this is tension 1 and this is tension 2. And here is G. Considering that this is not doing any tension, we know that mg equals 0. Okay, look at this formula. When finding the work done by the force tension when lifting a mass M, since the tension force T is the same direction as the displacement H, we know that the work done is equal to HT. Acting on M is T minus mg, which is equal to ma. Therefore, T equals ma g minus a. So, from the solution to question 1, we know that A equals G times M minus the other mass times M plus the mass. So substituting for A, we get this equation. In the percent error, we know that the elevator weighs 70 grams and the counterweight weighs 76.2 grams. So if we subtract this, it gives us 6.2 grams over the actual one, which is 70 grams, is 0.08 times 100 equals 8% error.
After all we've been through today, we have learned a lot indeed. So please tell us what struggles do you have while making the elevator, and what changes do you have to do, and what safety regulation about the elevators do you have to have in mind with all of what you did?
Okay, first of all, the first problem we encountered was that the cable that we used in the beginning broke because of how strong, how heavy the elevator was. So we had to change the cable at the string completely in order to be strong enough to lift the whole elevator and also to hold the counterweight, because the counterweight has to be the same weight as the weight in the elevator. After testing the elevator, it's important to know how certain materials are necessary in order to build a perfect and safe elevators for the passengers to be completely safe when they go inside the elevator. So many ideas were found after going over the different problems that the machine we made. First of all, it is important to know that the elevators use steel cables to lift them and hold them in place for more safety. We found out that the machinery of the elevator is so important that it can fill a whole penthouse on the bottom of the elevator.
Wow.
That's
Yes.
a lot.
Yeah.
A counterweight chosen to weigh about as much as a cab with 40 to 45% of the full load lessens the motor output needed. But when an empty elevator must go up, the heavier counterweight provides too much energy. The same resistance is needed when a full cab heavier than the counterweight is descending. And the elevator cable is rated to hold about 125% of the maximum full car weight. And 5 or more cables have to suspend the elevator in order for it to go up. It's not only one cable, it's 5 or more in order to
Hold it up together.
Yes, and to make it
Okay.
really safe, because many problems have happened with elevators because of this.
Well, it's very interesting, I think. And well, my son asked me this morning how the elevators work, but I really didn't have no idea about it. I think because of you, I will explain that to him. So thank you.
It is very important also that the presenter explained previously on the calculations happened because of the friction that were in the spindles when the cable was moving. This is why this percent error happens, but this usually doesn't happen because real engineers we have to calculate those things in order for there not to be friction.
In order for it to work perfectly.
And the elevator is so heavy that the friction in the real elevators don't matter. So this is what happened in our project.
So it was a pleasure for your interview. Any question your son have?
You may consult us.
Yeah, all the question was all mine. Thank you very much.
Thank you, James.